Okay, today's lesson is section 7.3 and it's on inscribed angles. And this is the last day of notes for you guys, so you should be pretty excited. So, with an inscribed angle, it's an angle whose vertex is on the circle. So if you look here, it's different from yesterday. So inscribed angle's vertex is on the circle, not in the center of the circle. And that's what it says. An angle intercepts an arc if the endpoints of the arc lie on the interior of the angle. All right, so a fact that we know about inscribed angles is that this angle will be half the measure of the intercepted arc, which is that arc between the angle. So if I told you that this arc was 80 degrees, that means this angle would be 40 degrees, okay? And then if I told you the angle was 50 degrees, that means the arc in between my angle would be 100 degrees. So think of it like as a slice of pizza, and the arc is the crust of that one slice of pizza. Okay, so for example 1, it says circle F here to the right, the measure of arc WX, so this little piece is 20. Maybe I should do it not in. Okay, so this little piece is 20. X to Y is 40. U to Z, so U to Z is 108. W to U is equal to Y to Z. Okay, so it says find the measures of all the numbered angles. Okay, so in order for me to find the measure of all the numbered angles, I have to find the two pink arcs, so the U to W and Y to Z. So we know an entire circle is 360. So that means if I take 360, subtract 108, and subtract 60 because I added the 40 and 20 together, I'll show you guys here. So if we do 360 minus 108 minus 60, we get 192 degrees left to split between those two. So if I divide that by 2, we get 96. Okay, so that means this is 96 degrees, and this is 96 degrees. All right, so now for me to find each numbered angle, I need to look at the angle. So angle 1 is from here to here. So the arc that is in the middle is right there. So that means for the measure of angle 1, I just need to take half of 96. Okay, and that should be 48. So 48 degrees. Okay. Moving, 48 degrees. There we go. Okay, so now if we want to find the measure of angle 2 goes from here to here, which means 40 is in the middle. So the measure of angle 2 is half of 40, so that means that's 20 degrees. Then we look and say, okay, here's angle 3. Angle 3 is there, so half of 108 is 54. Okay, the next one, angle 4. Angle 4 is there. Now, if you notice, angle 4 is not an inscribed angle. But angle 4 is part of this triangle, and I know angle 2 and angle 3. So if I know 2 of the angles of a triangle, we simply subtract them from 180. So that means, let me bring this up just to do it on here. So I need to take 180 minus angle 2, which is 20, minus angle 3, which is 54, and that leaves the measure of angle 4 as 106 degrees. All right, and finally they're asking about the measure of angle 5. So there's my angle 5. Here's the arc that goes between it. Well, look, that one's also 108 degrees. Okay, so hopefully that makes some sense. The next theorem, it says, and we sort of already just did this with angle 3 and angle 5, it says if two inscribed angles of a circle or congruent circles intercept the same arc or congruent arcs. Then the angles are the same. Okay, so that's all that says. And we really just did that with angle 3 and angle 5 because they both had that arc that was 108 degrees. So here's our example 2. It says points M and N are on a circle so that MN is 72. So before I do anything else, I had better draw my circle. Suppose point L is randomly located on the same circle so that it does not coincide with M or N. What is the probability that the measure of angle MLN is 144? All right, so we're actually just going to skip this example today. This is one that I don't have to do with you guys in elements. So lucky you, I'm sure you're all very sad, but we're going to go ahead and skip example 2 and move on to example 3. All right, because now we're getting into the more of the algebra part. Okay, we don't need to worry about probability. So 2 more facts, and they should come as no surprise, but it says if an inscribed angle of a triangle intercepts the semicircle, that makes it a right angle. And that should make sense because if this right here is my angle and it intercepts half my circle, well, half a circle is 180. The angle is half of that, so half of 180 is 90. All right, and the last fact is if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay, so opposite angles in a quadrilateral, most of the quadrilaterals we looked at are supplementary anyway, but this is just saying because it fits into this, so it tells you specifically there. All right, example 3. It says triangles TVU, so T to V to U, so that's this triangle, and triangle TSU, so T to S to U is that triangle, are inscribed in circle P, and it's also telling us that V to U is equal to S to U. So those 2 segments are the same. Find the measure of each numbered angle if angle 2 is x plus 9 and angle 4 is 2x plus 6. You can just ignore one of those equal signs. Okay, so we have to find each numbered angle. So we can find 2 and 4 pretty easily because it is a right triangle, and we know that all 3 angles of a triangle add up to 90. So we're going to end up with 3x plus 15 equals 90. So I subtracted 90 from both sides to make my number smaller and then combine like terms. And then I'm going to get 3x is equal to 75 if we subtract 15 from both sides. And that's going to leave me with x to be 25. Okay, so x is 25. So one thing we know about these 2 triangles is that they are congruent. Okay, so if I find angles 2 and 4, that means 1 and 2 are the same, and 3 and 4 are the same. So let's plug that in. So for angle 1, which is equal to angle 2, that is equal to 25 plus 9, which is 34. And then angle 3 equals angle 4, which is equal to 2 times 25 plus 6. So they are each equal to 50 degrees. 56 degrees, sorry. 56 degrees. There we go. Now that looks good. Okay. And I believe we have one more example. It has to do with our quadrilaterals. So it says quadrilateral QRST is inscribed with circle M. If the measure of angle Q is 87 and R is 102, we have to find S and T. So this is the fact that you need to remember that opposite angles are supplementary. Okay, so remember, supplementary is when 2 angles add up to 180 degrees. So I'll call that one X and call that one Y, although I could call them T and S. So in order to find X here, all we have to do is subtract 102. So 180 minus 100 is 80. 80 minus 2 78 degrees. Okay, so I'm going to say the measure of angle T is 78 degrees. And we're going to do the same thing for S. So we're going to do 87 plus S is equal to 180. If I take 180 minus 80, that's 100. 100 minus 7 is 93 degrees. So the measure of angle S is 93 degrees. Okay, so I do want you guys to try the your turns. Okay, you can skip your turn 2 because we don't have to do anything with probability. And if you're at all upset, I can go over that with you another day. So I want you to do your turn 1, your turn 3, and your turn 4. Make sure you submit your notes, please, and then work on the practice work pages.